Okay, we're going to debug Nagon. Remember how it doesn't fit on the screen, right? We were looking at that all wrong. I think we need to use the symmetry of the polygon to make it fit on the screen. We weren't quite there. We're like just shifting it certain distance. Yeah, that didn't work. So let's fix this. Go open up your Nagon. All right, where's my Nagon? Here it is. All right, now notice what I got here. I have from arg0 how many sides? Okay. The length of each side, I called it step, is the sine of pi radians over the number of sides, right? So as n goes infinity, the circumference, it becomes a circle with a circumference of pi because the diameter is 1 and the radius is 1/2. The angle that we're turning is 360 divided by the number of sides, and we initialize the turtle at 0, 0, 0. All right, so let's see what that looks like. Do you have that? Make sure you have that, same thing. All right, so we're inputting arg0, step is pi over n, angle is 360 over n, and then I called it poly is turtle 0, 0, 0, and I didn't change the loop or anything. All right, now what I want to do is adjust this so that using the symmetry of the polygon, I can actually fit it on the screen that I had, okay? I think what we had to do, what we were trying to do was just translate it left to right. That's not enough. I think we have to rotate it too. Look at it. If you run it, Nagon 5, say. All right, you get a pentagon, but it's pushed off the screen. So what I'm thinking is, whoa, where did it go? Where are you? Come back. What I'm thinking is, why don't we start drawing in the middle of the x-axis, the middle of the bottom of the screen, and then rotate it so it fits, so that half the pentagon is on the right and half the pentagon is on the left. That should work. All right, let's try that. Let's move it. Let's do a translation, like we said. Whoops. Let's translate over half a unit. Yeah. It gets shorter and shorter and shorter until eventually you have like a circle going on. Well, yeah, but the thing is, remember what we're trying to do is what we have is a window which is a square of unit size, right? 1 by 1. Okay, well, I'm going to try this. Hang on, look what I'm thinking here. Let's just shift it over, translate it over 0.5 to start. All right, save that, run that. All right, so Java see it, Java it. And it's still bad, it's going off the screen, but don't you see that if you rotate it a certain number of degrees, you can actually get half the pentagon on this side and half the pentagon on this side, pivoting around this point? How much do I have to rotate around this point? How much would you rotate the polygon to start, the very beginning? I don't want to start going east. I want to start going, rotated from east, 0 degrees. How much do you think I have to rotate it so that it'll fit on the screen, on the graph screen? Or what they call the canvas. This is called a canvas class, because you're an artiste drawing on a canvas. Huh? 45 degrees? But is it always 45? Let's see. All right, let's go over to the code, and let's put in 45 degrees. And let's save it. And let's try that. Well, okay. 45. But what I'm trying to do is see if I can draw it so it has vertical symmetry. So I have exactly half the polygon on the right side of x equals 0.5 and exactly 1/2 of the polygon on the left side of x equals 0.5. So no matter how many sides I have, it fits. 0.5 for x, yeah. Yeah, I'm just starting in the middle of the screen at the bottom. So 0.50. Yeah, so 45 is too much. It has to do with the number of sides, because what if I change the number of sides? What about 3? Yeah. Couldn't we draw this so that this pivot point is the center of the triangle and this side is actually horizontal? Couldn't we turn it a little bit more? Is it always 45? I don't think so. I think it has to do with the angle we got in here. All right, let's play with that. What if I put in angle? Right? Didn't we calculate the angle here? So we can put it here. Angle. All right, save that. And run that. Java C. The angle that we calculated was 360 over n.
We're just starting with it, so we're initializing and then we're going to turn.
Initialize it first, right. Now that's too much. It went way too far. Now wait, let's see what happens.
Say it was 45 degrees?
Well, I tried 45 and that wasn't good enough. Then I did angle. All right. Yeah, that's too much too, isn't it? 35 always works, no matter what the shape is? It works for 5. I want to try and make it general so it works for any number of sides. Well, I'm thinking that angle is too big. Let's make angle smaller. How about half the angle?
Ooh, here's a question. How about...
There it is. Perfect.
How about 360 divided by 2s?
2s? Okay.
Well,
Hang on. Look, what if I do 3? Does it fit now?
Well, I
Yep.
just did for 3.
What if I do, I don't know, 6? 6 sides.
You just make it upside down now. That's silly.
There you go. There's your hexagon. It fits perfect now. All right?
Silly.
So the trick was to get some sides vertical or horizontal. That was the trick, to get this to be the pivot point so you have an axis of symmetry which is vertical.
Cool. Now it's only upside down shapes.
Okay, well, that's all right.
How do you flip it? Is there a...
You could write it so it starts at the top and it turns the other way. There is, if you take a look at standard draw, there is a
invert the result?
there's a thing to invert the graph paper before you start, I think, yeah. Instead of making 0, 0 at the bottom left-hand corner, it's top right, top left-hand corner, and it draws down instead of drawing up. You could do that too. If you take a look at standard draw, it's in there. All right, so this works nice. Now remember last time we did 10 sides and it didn't fit right? Let's see. There it is. And notice what happens is, as the number of sides gets bigger, the sides get shorter, and you get more and more like a circle, don't you? How about 20 sides? There you go. There's 20 sides. It's more and more like a circle. All right, so here's the code.
And here's for 500 sides. Or a slab.
All right, so that worked. So we shifted it over a little bit, and we rotated half the interior angle. Well, actually, the exterior angle.
Well,
So it would have fit nice, okay?
actually, since I want to see the end result, I don't really care about how it fits there.
All right, so is everyone done with Nagon? Is it working? Who's stuck? Anyone stuck with Nagon? I tell you to print now, but the print network is down, so we'll print some other time.
With or without the shell, it takes forever doing files.
Really? Wow.
Look how slow it's going.
Yeah, I saw it. I know, I saw it.
I improved the shell.
All right, so make sure that, you know, your pentagon, your octagon, all that stuff works nice. What happened here? What happened? Yeah, it's off the screen. Why?
I didn't shift it also.
Yeah, this process is stuck. I wouldn't cancel it here. I would cancel it here. Yeah. Anyhow, let's see. So the sine of pi over n radians, n is the input, right? 360 over n, 0.5. Isn't that exactly what I have? Go forward a step, go left an angle. What is missing here? This is saved, right?
Still my turtle, but I think I thought
Wait, I think there was a thing here that said it didn't save, so it was running yesterday's code. Where's your shell? No, that's it. Okay. No, that's not it. Okay, go away. What the heck? Where am I? There it is. Why is it doing that? It's starting at 0.5, I guess. But then it's going like this, and then it's not going. It should be going this way, right? Well, it's going the opposite way. Why?
then I messed up. I turned it the wrong way.
Yeah, but we only have a turn left, so that there's no choice.
Maybe I wrote
You-
turn left as like different.
Oh, maybe your turn left is weird in turtle. You're saying? Maybe. Where's turtle? Let's see. Let's make this big. Turn left. No, just add delta. That's all. That's fine. Anything else weird in here? This is backwards. Cosine. You get the x component of the vector with the cosine. You get the y component with the sine. Remember?
Yeah, that would
Yeah, when we've done that a million times? Okay, so in the math class, you know that math class we take, third period? All right.
I thought
Yeah.
we just go on a computer.
All right, so anyway, where the freak is your shell? Come on. Oh, it's there, okay. So let's see if that's all it was. That, your turn left was messed up, but, okay. All right, who else is stuck? Who doesn't get like a nice pentagon or octagon or something? Stuck, stuck, stuck? Nobody? Yes? Yes? You good? You good? Ooh, look at that. Ooh, nice. Where's yours? Let's see it. Hey? Is it done? Oh, God.
Looky at my bygone.
Poly.go go forward. You can't find symbol. Go forward. Well, do you have the turtle class?
And did you call it go forward?
Where's your turtle class?
And
There
did
it
you
is.
spell it properly?
Oh, this is turtle. Oh, what happened here? Oh, you already have it open, right? It's there. Okay. La 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 la. Go. Yeah, forward is spelled different. that'll mess you up.
Look, here's my 0 gon.
Zero gun. Okay.
Look, and then here's my 2 gon.
There's your two gun. What about your one gun?
1 gon just makes it spawn 1. Because it keeps going back and forth between itself.
Yeah.
Well, I want to know what happens if you do negative 1.
Oh my God.
It actually runs.
It actually
At
runs.
negative 1. And let's do, what did Archimedes use? A 3,000, what sided? 3,090?
All right, your angle's a little bit off though. Still. Let's see. Where's your
It should be divided by 2x.
Whoops. Where am I? Where's your
Alt M.
and gun? There it is. Okay. Oh my God. It's already open over here. Stop it. Jeez. Okay, what happened? That's right. That's right.
Don't
Not
do it by
45.
angle,
This
do
is
angle
angle over
divided by
2. Yeah, we wanted to change with the size of the angle. So angle
Oh,
divided by 2. So as the angle gets smaller, we rotate less. So it fits
oh, that
nice.
isn't how I did it. Okay.
All right, try that.
I didn't
Oh
put
wait,
it in there.
we're still running this, so we can kill that. Then go. Ta-da! Okay, good. All right, who else is stuck? Anybody? All right. Now, let's go back. Listen up. Shh. Let's go back to DrunkTurtle. Let's see how DrunkTurtle is doing. All right, let's see. Do I have a DrunkTurtle that's working here? Let's see. DrunkTurtle, Java, DrunkTurtle. Let's see. 100 steps at 0.1. Does that work? There it is.
Oh, you need a lot of stuff.
There's my DrunkTurtle. Does your DrunkTurtle do that? Let's see. 0.01.
Inebriated, not drunk.
Here's my inebriated turtle. Yeah, I need a lot more steps. How about? All right, if you.
Wait, is it 101 or 100?
I have 100 and 0.01. There you go. There's your random walk. Now, if the random number generator is really, really random, it should stay near the initial point. It shouldn't really go too much beyond this screen. So that's the turtle that's drunk. If we really want to make this a turtle, by the way, it should probably have like a little green creature walking in the front. But yeah. Yep. Let's see. So here's my my drunk. Where the heck is it? DrunkTurtle. All right. So here it is. Now, do you have this? All right. So arg0 is the number of steps. args1 is the step size. I started at 0.5.50 for the turtle, and then I just went n times an s distance, a random number times 360 every time. Now, what does that mean? Well, math.random returns what? What is?
This is rather random.
Well, that's the idea.
But the
Math.
turtle, it goes on the screen.
Well, your turtle's too
and
humongous.
It's just my circles are too
Yeah. All right. Listen, guys. Shh. Math.random returns what? A double between 0 and 1. So at most, it's 1 times 360.
divided by infinity.
Well, actually, it actually doesn't actually give you 1. It gets you very close to 1, and you can get 0. So if you multiply this by a number near 1, it's almost 360. A number near 0, it's almost 0. You're going to get all kinds of doubles for your angle between 0 and 360, pretty much. That's why it's turning all over the place. All right, but that's not what I had in mind. What I want to do is input another arg. I want to input the turn angle. so that if I input 90 degrees, it always turns 90, but it can turn 90 or 180 or 270 or 360.
But if you put something that's not a multiple of 360, won't it go to every single angle?
Well, that's the thing. I want to make sure it's only a multiple of 360. So what I have to do is I'm going to add another args to this. Is anyone stuck? Does this work for you guys? Is it doing this?
And the cool part, it'll almost never be the same.
Right, that's the whole idea, yeah.
Be the same. It's incredibly small.
Let's see if I can fit this over here.
The only way for it to be the same is they have to be the same for every single turn. And I'm running 1,000 turns. So it would be 1 out of 360 to the 1,000th.
Right. Okay, so there's the code, there's the run. Who's stuck? At this point. It should look, wacky. Let's see, I'm trying to fit the code.
I made it 0.001, and now it's just kind of vibrating.
It's vibrating.
Oh look, it's just bouncing back and forth.
All right, so this is basically the whole code right here. Okay, so who's stuck? All right, so we got to get this working first before we get. This is called a random walk. It's the basis of Brownian motion.
It's not a very long walk.
Okay. Well, yeah, because we're telling it how many times to move and how far to move each time. Well, that's different. What happened now? All right, let's X this out. Oh, you didn't X out. These are just dead processes stuck there.
That's a lovely tip.
All right, so where is your code? Here it is. So n is the number of times you're walking. S is okay. Oh yeah, be careful. S is a double, right, guys? I'm plugging in like 0.1, 0.01, right? So it doesn't move too far. So S is a double. So double S equals double dot parse double. Don't do integer dot parse int, and don't do int here either, right?
Does it matter for the first one? You can make it double.
You can make them all doubles, I guess. But this is going to be an integer, and this is going to be a decimal. Yeah.
Yeah.
I can't print. The printer's down. Yeah, it's just those few lines right there. That's why it's sitting there. Okay.
I feel like this is like the sphere of influence of like civilization, and now it's just like pooping out.
It's trying to take over more territory, huh?
Yeah.
Are those like eyes of the
Yeah.
turtle? Yes, okay.
The
I had to
there
ask.
are other eyes, and they've just been
They just,
overwritten.
that's a problem with eyes, yeah, I know.
But it looks slightly more turtly than your mind.
Right. All right, who's not getting that kind of output? Who's stuck?
Wait, you know what'd be cool? Is if we created 2 drunk turtles on the same screen and battled them.
Yeah, we could do that, but
Like color.
I'm actually after a dragon fractal. Hang on. You stuck?
Like, I'm no joke, I think that would actually be really cool.
Yeah, that would be cool. What if they like bang into each other, they like turn around or something?
No, they just cover each other.
Oh, well,
Make it easy.
I think I've done that with multiple turtles, and if they bang into each other, either they turn or explode or change color. Okay, where are we? Is this is, what is this?
That's what,
That's the other one?
when I put it in.
Oh, that's all you get from DrunkTurtle?
Yeah.
Well, oh, okay. Well, okay, get rid of this. Yeah, the thing is, you have to make the steps. You have to see a lot of steps, and you have to make the step size sort of small. No, that's different. Let's see. Again, this is a double. Capital D. Yeah. All right, you saved it? Let's try that. Whoops. Ding, ding, ding. Where's the Java C? There it is. And then the Java, that one. That's more like it. Good. All right. All right, who's stuck? Because I have to have this working before I do the next step.
I don't have turtles at all.
You don't have turtles at all? Well, look on with someone else's turtle. I can't print today. What happened? What did Well, because it's looking for input, right? It's doing args0 and args1, so you need like 1,000 and no space. Then like 0.01. All right, that should do it. And you got it. There it is. That's it. Great. Good. A random walk, random walk. All right, who doesn't have a random walk running? What's it doing? Well, yeah, because remember in the code, we're asking for input from args0 and args1. So that means right here,
It's still going.
put in like 1,000 for how many steps,
It's still going.
space,
For like 10,000.
like 0.01 for how far to step each time. Enter, and that should do it. There you go. Good.
It's still going. Now I'm gonna make it. I'm Xing this one out, and I'm gonna go Java C it.
Yeah.
And,
Oh God, what now? Ah, you broke it. Oh, you broke it again. Huh? Yeah, yeah. Well, until it burns your hand off, then it's not. It's hand sanitizer until it's not. Okay. All right. So this is what I want to do. I want to input a specific angle, like 90 degrees or 60 degrees, and I want it to only turn a multiple of that. So if I input 90, I want it to go 0, 90, 180, or 270. Just that. If I plug in 60, I want to go 0, 60, 120, 240, like that. Okay. Right. Yeah, because look at your code. It's looking for input from args, right?
Okay, so
So that means that you have to say
So what, one-
something like 1,000 for how many steps, space? No. What? 1,000 space. Then how long each step is, like 0.01. So you see a whole bunch of them on the screen. Enter. And that'd be it. Yes, it is. Ta-da! Okay. All right, so how are we going to quantify? This is a quantum turn. You know, like quantum mechanics? I don't want any old decimal between 0 and 360. I want it always to be 90, always to be 45, always to be 60, if that's what I enter. So I have to enter another args. I need another args for the angle that I'm turning. Then I don't want to multiply by random. I want to multiply by a random integer. All right, let's see. What if I want 90 degrees? So instead of 360, I have 90 times what? How am I going to get the 90 degrees that I input to become 0, 90, 180, or 270? Or if I input 60, I'm going to have 60 times something, so I get 0, 60, 120, 180, 240, or 360. Or 300, sorry. I have to have this random number return an integer, like a die roll. If you roll a die, what do you get? Standard die, what do you get? Guys, focus. It's 1 through 6, right? So if I plug in 60 times a die roll of 1 to 6, don't I get multiples of 60? Everywhere from 0 to 360, right? I have to figure out how to make math.random return an integer number of times I want the 60 to count, or the 90 to count, or the 45 to count. Any ideas? All right, well, let's add another args. Just get the inputted angle in there anyway. What is it, a horse race?
No, they're gonna fight, but they haven't touched each other yet.
Okay.
You make them closer, but I mean.
All right, let's add on another args. How about int a for angle? So I'll put that in my interpreter line, the angle, okay? Equals integer. Yeah, I wrote it in Brooklynese, sorry. Parse int. Now let's make that args 0. So this will be, I don't know, the angle, I guess. Just write that, just the angle there. I put little comments here just so I won't know what I'm doing. Now, if that's args0, this has to be args1, and this has to be args2, right? All right, so what I want to do is I want to take the angle that I inputted, the A, times an integer number of times that A goes into 360. All right, so how many times does A go into 360? So if it's 90, it goes 4 times. If it's 6...
Lobotomy thinks we have.
Okay. Fine, be that way. All right. So how about if I call that, well, all right, let me put this here. All right, how about this? Int choices, the number of choices, right, if it's a 90 or a 180, equals 360 divided by A. So if A is 90, you get 4. If A is 60, you get 6, right? Now I'm going to take my math.random. Where is it? I'm going to take my math.random, and multiply it by choices so that it's a number between 0 and 1 times, say, 6, right? But it's a decimal, right? I don't want that. I want an int. How do I cast this to become an integer? Say it gives me 5.9, I just want the 5. Or it gives you 4.8, and I just want the 4. How do you cast to an integer? Do you remember? No, nobody remembers how to cast? Take that whole thing, in parentheses, and put in front what you want to cast it to. It's a double right now. Remember, random gives you a double, right? Open parentheses, int, close parentheses. What that does is it takes whatever this is, say 2.9, and intifies it, makes it 2, multiplies by the angle, say 90, and now you have 180. So if random is a number between 0 and 1, times, say, 6, it's a number between 0 and 6, not including the 6. Intify it, it's an integer between 0 and 5, times 60, you get 0 times 60, or 1 times 60, or 2 times 60, or 3 times 60, or 4 times 60, or 5 times 60. That's it. All right, so let's save it like that. Okay. I think he might want more colors than that.
Yeah, I know.
Yeah.
I might add some more, but still.
Okay.
I think this is a pretty good fight. Who do you think won? I think it's red.
All right, let's Java C this thing. Where's my Java C? Do I have a Java C for drunk? I don't. All right, clear. Java C, DrunkTurtle.java. And then run it. Now remember, now it has 3 args inputs, right? The first one is the angle.
The first blow.
The next one, what was it?
Red, green.
The number of steps, let's say 1,000.
Green.
And let's say, and the size of each step, I don't know, 0.1.
Red and green and red and green. There's literally.
You see what you're getting? You get what's called a tessellation. In fact, if you have regular polygons in here, like this looks like an equilateral triangle, this is known as a dragon fractal. The edge of this is fractal.
Wait, what angle did you use?
60.
I want to see if my turtles do that.
All right, look, what if I make it 90? It only turns 90, a multiple of 90 each time. So 0, 90, 180, 270, right?
You need to use more.
So now let's throw in more, right? So let's throw in, okay, let's throw in more steps
Okay, this is
and make them
slowing down.
smaller.
Okay, this does not work with turtles.
Yeah, that's a problem. And if you do this long enough, the edge of this becomes a fractal. It went off the screen. I got to make this smaller.
Yeah.
Yeah, let's make it
Sorry,
smaller.
these turtles, they're not going to cut it.
Yep. So I get my dragon fractal. There it is. Come on, dragon.
I'm sorry, these turtles, they're too big.
It's a little laggy, though, because everyone's doing it, so. All right, let's go back to the code. Where's the code?
This is not going to work.
Okay, there you go.
Sorry.
All right, so choices. All right, so say angle is 60. 360 divided by 60 is 6. So I have 60 times 6 times the decimal between 0 and 1. So it gives you a decimal between 0 and 6, not including 6. Intified, you get integers 0, 1, 2, 3, 4, or 5 times the 60, so it gives you a multiple of 60. 60 times 0, 60 times 1, times 2, times 3, times 4, times 5. So you can get an angles like 0, 60, 120, 180, 240, and 300.
Red, dominating.
Okay. Let's see, run that again.
Look here, green went off the screen, so red is just owning everything from green.
All right, how about 60 degrees? Did I do 60? No, how about 45 degrees?
And red's returned, eating the rest of
Now it's looking a little bit more like the original random walk. You're not getting a lot of structure out of that. So I guess it has to be a multiple of 30, the angle. All right, so there you go. All righty. Tomorrow we're going to talk about Koch fractals. All right, bye-bye, YouTube. Where are you? See you, YouTube.
They're called Koch.
Why isn't YouTube going away? Bye-bye, see you tomorrow.
There's like so many different ways of pronouncing that name.
Which one?
Koch.
Yes. All right,
Finger
so...
Koch.
Okay, YouTube, go away.
That's how the fractal video pronounces it.
Oh, really? Yeah, that's true, it does. All right, I'm going to have to do this hard way. Come on. Come on. See ya. Nice to know you. All right, come on, finish this thing. Bye-bye. There you go. Let me get rid of... Oh, this is messing me up. All right, get rid of this. Get rid of this. All right, don't get rid of this. Get rid of this. All right, there you go. Now let's see if we can get the video. Come on, video. All right, so open Pro Tools. Let's force to quit.